So I wanted to go ahead and do a live programming example of a 1702A on the second spin of the PCB, the version 1.06 card. So we've got the programming board in the machine, the high voltage transformers plugged in, so we've got the active plus 47 on the board. Let me go ahead and reset and boot the Altair. And we're booted. If we look at the B drive, I've got various programs on here, including there should be PGM6 right here, someone we want to load. Load from drive B. PGM6.basic, and we'll talk a little bit here about the program as it's currently written. It certainly doesn't have to be structured this way. So basically I'm defining 8 variables that define the start addresses of the 1702. So what I'm doing is I'm reading from upper memory, and I'm using the contents in upper memory to actually program the ROMs. In this case, I have the Altmon ROM set and the combined disk bootloader and everything card in the system, and so this address space is actually already occupied by ROM, but for my demo here this will be good enough. And this was written to actually program the 8 ROMs that go on to that card, but it could take any contiguous 256 byte block in memory and program that into a 1702. So I'm just going to go ahead and I'm going to program another copy of the combined disk bootloader that happens to start at address FF00 and run through address FFFF. So the program wants me for a ROM number to program. In my case it'll be 7. If ROM is 7, then it sets the starting address to this variable FF00, which is actually this value. It's going to ask the number of programming passes. So normally when you trigger the programming pulse on the programmer, it does 1 pass to that address. I've modified this where you could specify up to 5 passes per address. At 5 passes per address, the part gets really warm, so 5 is really probably too large. Make sure you picked 1 to 5. I need to define the ports that the card is on. So base is the base port the card is strapped to, which happens to be 192 in my build. And then you take that 192 plus 1, you get the port where you latch the address to be written in the EEPROM, plus 2 is, let me step back here because I'm saying this wrong. Let's see. So port 192 itself, you latch the data to be written to the EEPROM. 192 plus 1 is the address to be written to the EEPROM. Simply doing a read or write to port 192 may only be a write only. To 192 plus 2 will trigger the programmer, and then on port 192 plus 3 you can check the status. We're going to program 256 total addresses. We're going to peek at the current memory contents at which one of these starting addresses was set. In our case it'll be FF00 plus A. Going to go to subroutine 170. We're going to latch the data to be written. This is the value we peeked up here. So we're going to latch the address out, which happens to be A. So remember, A is the address on the EEPROM itself on the 1702, and the offset to get the bytes from memory. So it'll program addresses 0 and 1 then 2, basically telling us it's doing something. It's got some code in here that does some looping to give you a visual display. Comes into a loop here for the number of passes. Does that out to the base port plus 2 that says, hey, trigger a programming pulse. Checks to see if it's done. If it is done, it goes to line 315. Otherwise, it loops till it's done, and then goes through the next address. The next address as it loops around here. So that's really all the basic code does. Like I say, this was written specifically for my programming needs. You could modify it for anything you wanted. You could actually ask the user for the starting address in memory that you wanted to program and use that instead. I mean, it's very versatile and really easy to modify because it's written in BASIC. So let's go ahead and run it. And it's going to ask us for the ROM number. I'm going to make a copy of the ROM I happen to have at the top 256 bytes of memory, which is ROM 7. It's asking for the number of programming passes. I'm actually not remembering here if it'll prompt me to put the EEPROM in or not, but I can load one up safely now. The pin 1 notch is to the bottom left over here. Let's get a part in the socket. During programming, hopefully the red LED over here will be visible. It'll come on for each address that's being programmed. So I'm just going to do a single programming pass. And the LED should be blinking, and it is. And you can see it here on the screen where it's reading that high memory and then programming that byte to address to 0, etc., etc. And this will just loop away here. If we'd told it to do multiple passes, we would see a pass 2 number here and some periods, a pass 3 number. I'll actually demonstrate that here in a second once this pass gets done. The thing to keep in mind here is I have no way to verify in that programming socket that the part's accurately programmed. That would require a fair amount of modification to the circuit. It's just something I haven't approached yet. So the machine's happily chugging away here. Not a whole lot to say here. You know, the values being output here are in hex, so address 5D just got a 09. We're not quite halfway through yet. And as you saw, this programming software is completely written in BASIC. It could be written in a different language, but BASIC is going to be, I think, the quickest to actually make changes to and test. You actually don't have to have an EEPROM in the socket to program. You can test your software with a blank socket or an empty socket. So we're past halfway. We'll just let it keep chugging here. The part I have in the socket, I believe, was actually previously programmed and not erased. So, you know, this part's going to end up with a bad bit pattern in it, but that's fine. I can erase it and reuse it. A note about the 1702A is it erases to all zeros, and then you program in ones. Starting at later generation EEPROMs, it actually erased to all ones, and you programmed in zeros. So it is, you know, a change, a little bit different way of thinking, although it's not that big a deal. Let's let this keep looping here. And we're getting close. We've got to get through the rest of D, E, and then the F space, and we'll be done. Almost. Keep programming. I'll demonstrate a couple other programs here in a minute on the machine just so you can see them as well. But let's let this get through and finish this pass. So it's done. The red LED should be out, and it is, and that says, hey, we finished programming, and the high voltage should be disabled to the socket. I'm going to go ahead and pull the part out. And I'm going to program an empty socket in this case, but I want you to see what happens if we enter multiple programming passes. So in this case, we're going to pick that same ROM, and I'm going to do 3 passes per address. And you'll see the behavior change here where it's telling us I'm doing pass 1, I'm doing pass 2, I'm doing pass 3. The number of loops it takes to produce a period is it is increased depending on the number of passes so that it doesn't wrap off the end of the line. But this would allow you to hit each address multiple times if you wanted to. The preferred method from the vendors of programming a 1702A is apparently make a full programming pass with the programming spec, verify the part. If anybody didn't program, make another pass. If a byte didn't program, and continue until you get a good, every byte in the device is programmed correctly. And then you over-program at some number of additional passes. Because we don't have the ability to read the ROM in this, there's really no way to implement that. So, you know, programmer is what it is. It's not perfect. I think I can go ahead and do a load B. I think it's ROM CKSM1.basic, I hope. I don't remember now. There's probably a way to get a directory inside of BASIC. I just don't remember what it is. Test checksum 2. It's this guy right here. I'm going to load this one up. We'll talk about it for a second as well, because it's another part of this. So in this case, I've got the 8 1702s are previously programmed into a card in the S100 machine, and it is the active ROM. It's the ROM we booted the machine from earlier. If I load B:TSTCH CKSM 2.basic, what this little program does is it verifies the checksum for each one of those 8 1702As I previously programmed. I ran into an issue where of the 8 original ones I programmed, I had 3 of them actually lose bits after a period of a couple of weeks. And when I discovered that, I pulled those 3 out and reprogrammed them and put them back in the board. So in this case, I've got 5 in the board from the original pass, a few videos ago, 3 parts from the second pass, and I'm just monitoring them every couple of days. I'm running this program to say, hey, have they lost any, have any ones flipped to zeros or zeros flipped to ones? Is the programming changed? I don't know if the 3 that had bits change were because I didn't program them hard enough. I don't know if they're just bad 1702s that are leaky, and are losing programming. I don't really know. But what this program does is basically define a start address for a ROM, define the ROM number on the board. I've got them numbered 0 to 7, and the expected checksum for that position. And if I run this, all it's going to do is look at, what I call ROM 0 checksum, ROM 1, ROM 2, and it just tells me that the checksum of the ROMs is still correct. So I'm still at a point where I cannot guarantee that this is getting proper programming into the 1702 for long term. If I start to see ROMs losing bits, I will most likely pull the ROM or ROMs that are losing bits, erase them, and then reprogram them, say with 2 passes or 3, and see if I can find a balance really where the the ROMs seem to retain data solidly. The programmer's not perfect. It does the job. So far, the set of ROMs I've got in there have been very solid. It was ROM 0, 1, and 3 that gave me issues about a week ago where they seemed to be losing bits. ROMs 2 and the rest have been programmed for a month or longer, I believe, and are just fine. So I guess that's really a pretty quick demo. I'm not sure what else to talk about here. In a previous video, we've looked at the changes I made to the board. We've actually made a couple of additional changes for a third spin of the board. That's covered in a video that'll be a previous video to this one. You've probably already seen it. But somebody had asked to see a demo with the board actually in action. And so this video is it. I hope it clears things up and gives people an indication if it's a board they might be interested in at some point. I guess with all that said, I'll wrap this video up here, and we'll talk soon.